So next, let us continue discussing our query mechanism. So we just talked about two situations. One situation is that our neighboring router does not have this route at all. Then we directly delete this routing entry from our database. This routing entry is no longer available. The second situation is our neighboring router. It has its own set of paths. There is another path to access our routing entry. Access to such a network segment. Then we can directly switch to our neighbor's path. Take its path to access the destination network segment. This routing entry can still be used. So next we talk about the third situation. So the third situation, if the router loses the EIGRP successor route, and there is no feasible successor route in our database. After sending a query message to all neighbors, it will immediately reach ACK. The neighbor will respond immediately after receiving ACK. It means that we know this message. After this, our neighbors. Our neighboring routers, how can this be missing a word? After that, the neighboring router then go to query the status of this routing entry. So, after the neighboring router checks the status. At this time, the third situation has occurred. If the neighboring router owns this route, and then the next hop of this route, it is the router that sends the query message. What is the situation, students? For example, this situation at this moment, R1, R2, R3, R4, and R5. For example, R1, we announced a 1.1.1.0, 24 routing entry. But now, students, isn't it? For example, R2, my original routing entry 1.1.1.0. 24 next hop address R1, R3 itself, 1.1.1.0. 24 routing entry. The next hop points to R2, R4, originally 1.1.1.0. 24 routing entry. The next hop points to R3, R5, 1.1.1.0. 24 routing entry, next hop points to R4. So if at this moment R1, we did a routing entry filter, we do not announce this to R2 1.1.1.0. 24 route. For R2, it's over at this time. What is the situation? So my routing entry is lost. What to do? We send our EIGRP query message to all EIGRP neighbors. Ask what happened to this routing entry. But for the neighboring router, we first reply ACK to check this routing entry. I received your message. I will check it. What did he find at this time? I have a route, but who is the next hop of the routing entry? It's you. A very serious problem has occurred at this time. What is the problem? For example, I used to like to use an example to talk for R2. So I did my homework. So I lent my homework to R3 to copy. Who copied it? Copied R2's homework. So our next hop is R2, R3. Who did we lend this homework? To lend this homework to R4 to copy. R4 copies whose homework copies R3's homework. Then R4 lends the homework to R5. R5 copied R4's homework. So the source of the homework tells R3. R3 tells him, this routing entry, I did all my homework wrong, I wrote the answer wrong. When it comes to R3, there is a problem. I copied my homework from you students, so you tell me now that you did it wrong. Am I not finished? Am I not embarrassed? I have to find a correct answer quickly. You are telling me bad news now. You do it yourself. I copy your homework. You did the homework wrong. R3 is dumbfounded. I got my homework from you. My route comes from you. He was dumbfounded at this time. What should I do? My routing entry might be over. You tell me you're done, I might have to be done. Hurry up and find someone. Hurry up and find someone to remedy. See if there are any other neighbors. EIGRP neighbor. Relationship. Are there any other students who can also do so? Who can also possess the answer to this question? What should I do now? First, tell my neighbor this news. Tell you, buddy, right? I did my homework wrong. Then what does R4 say? What does R4 do? First reply with an ASAY. Dear students for R3. If I receive a query message at this moment, tell me. Then this routing entry has a problem. Then I reply with an ACK and find my routing entry itself comes from you. Then is my route also useless, can't be used. My route comes from you, then you tell me you have a problem. Then should my route also fail. So I found, if at this moment in my routing table, there is no feasible successor route, there is no backup route, I have to look for one. Is there any other path for this routing entry? Can it still be saved? I will send a query message to all. My neighbors. If R3 has other neighbors, I will send a query message to all my neighbors. Send a query message again. Ask about this routing entry. Is there any other reachable path? For R4, reply with an ACK upon receiving a query. What do I find after replying with an ACK? I find that this routing entry is also obtained from you. Then R4 is confused. Then has my route also failed? I have to look for this routing entry. Is there any other reachable path? Can it be saved? Then continue to send to the next neighbor. Continue to ask. So when the neighbor receives our query message, the third situation, then the next hop address of the neighbor's routing entry is the router that sent the query message. Then it will send to its other neighbors again. A query message, because it knows its own route, has also failed. Hope to seek other neighbors. Other neighbors help. See if this routing entry is still reachable. Is there any other path? Then the neighbor router, that is, the neighbor's neighbor, send a query to the neighbor. The neighbor router receives the query message. Find that the routing entry is the router that sent the query message. Send to its other neighbors again. Now it's the neighbor's neighbor's router. The neighbor's neighbor's router receives this query message. Then judge again, of course. What first reply with an AC take? Then again, make a judgment judge the routing entry. Is there routing entry information, or say routing entry is there routing entry information? Next hop points to another path, or say there is route information in the routing entry. But the next hop is still the router that sent the query message. Make a judgment. Then if the next hop is still this router, if the next hop is still the router that sent the query message, then continue to send to other neighbor routers. For example, R4. Just now, I received the query. I found that the next hop of this routing entry is still R3. Continue to send to the back, until when up to the edge of the network, or rather, in this process, during this process. If a reply is received, it indicates there is no routing information. Then inform query its own router. Route is unavailable. For instance, if our R5 informs R4, then this route is gone. There is no such routing information. After R4 receives the reply, we send a reply to R3. This route is gone. Then R3 knows this route is no longer available. Delete the routing entry from the database. Inform RR2 that this entry is unavailable. Reply with a reply, entry is unavailable, R2 deletes it. In this case, students. Through such a series of operations, we have determined the routing entry for January 1st, 11 has no other paths, is unreachable. Of course, there is a second situation, or the neighboring router has another path. To this route, then switch paths directly. And reply to its own router with a query. Reply with a reply. For instance, now another situation. Now, for example, our R3 router. At this moment, for R2 I received a query. R3 received the query sent by R2. I replied with an ACK. I found that my routing entry next hop address is still R2. What to do? We continue to send query messages to the back to send a query. because I found that my next hop address is the router that sent me the query message still go through it. Continue to send queries to the back. Send to R4. If R4 has a path to access 1.1.1.0, for R4 1.1.1.0, 24 points to R1. After R4 replied with an ACK, it found. Then it has another path to access 1.1.1.0. Then immediately reply with a reply message for our R3. I found 1.1.1.1. 24. I originally went through R. 2R told me this path is not available. It broke down. I am now seeking other paths to help it find. Then there are other paths can access 1.1.1.0. So R3 immediately change the direction of the routing entry, point to R4. Then we reply to our R2 again, reply with a reply message. Then R2 knows there are other paths to 1.1.1.0. I can't receive the 1.1.1.0 route here. This entry is not available. I found another path. Can access 1.1.1.0, then immediately switch paths, click towards R3. So the routing entry is alive again. Went through once. This is the second situation in the journey. Then there is a third situation. Then the last situation. If this query message has been sent to the boundary of EIGRP. What is the boundary of EIGRP, for example, this diagram? In summary, our query, such a query mechanism, EIGRP query mechanism, all are when the router is lost under the circumstances of this routing information. Then we go to find this route. Is there any other path that can be accessed? Can this route still be used? Is it reachable? This is our query mechanism to converge. Find other routes to the destination site. For example, the 1.1.1.0, 24 route of R2. The next hop is R1 unavailable. R2 sends a query to R3. After R3 replies with ASAK, find the route is unreachable. The next hop of the route is R2, the route you gave me. You tell me the route is unavailable, so can I not use the route? Continue to send. Continue to send query messages. Ask my other EIGRP neighbors. After other routers reply with ACK, find out if it is still the router sending query messages. My route is drawn from you, so you have a failure now. I might have failed too. Continue to send queries until the edge of the network. What is the boundary? Such a boundary router of the network. So what is the EIGRP network? Boundary router. Except for the router that sends query messages to itself, there are no other EIGRP neighbors. For example, for R5. So I received a query message from R4. I found that except for R4, I have no other EIGRP neighbors. So what does it mean? R5. I am on this path of our EIGRP boundary router. I have no other EIGRP neighbors. When there are no other EIGRP neighbors to send queries. Then we have determined classmates for R5. I have determined I have no other paths to 1.1.1.0 and 24. This is our first situation. I received route entries from you. You tell me this entry is available now. I have no other paths to access 1.1.1.0. I have no other neighbors. Then I have to accept my fate, reply ACK, tell our router R4 the route entry has no other paths available. The route entry is really unreachable. My route comes from you. I have no other paths. I can't help it. So after R4 receives such a reply, sorry for the reply message. I know there really is no other next hop. There is no other path available. Why should I accept my fate? Database entry, deletion. Reply. Reply, there are no other paths. Then R3 found. He also told me there are no other paths. Really, there are no other paths. Database deletion. reply, reply, then R2 is gone. Finally, after such a long journey, we found the route entry. There really are no other paths, can access the subnet. The route entry is really unavailable. So delete this database entry, really from our database. This is the third situation of our query mechanism. Then the boundary router replies with a reply message. Inform that this route is no longer reachable. Yes, there are no other paths, the router that received the reply message. So finally I know the route entry has no other paths, so delete the database entry. Continue to send a reply to the previous router. So after such a forwarding, after this step of confirmation, so all routers know, then this route is no longer available. Remove it from the database. So this is the third case of our EIGRP query mechanism. This third case is more complex, because the next hop of our routing entry is the router that sends us the query request. After this third case, we discovered the true unavailability of the routing entry. Then delete it. Classmates. These are the three cases of our query mechanism. Of course, speaking of the query mechanism, we can also see this phenomenon. For example, let's do this experiment. What was the situation of the experiment we just completed? R3 has a free route to R2. Then R2 filters out the route from R1. So in our last lesson, we filtered out R3 on R3 after the 10.10.3.0 entry to R1. Then R1 sends a query message causing R2 to reply with a reply. We switch paths. R1 was originally going down. After the query message query collection, we go up to access 10.10.3.0 tested our second situation. So for the third situation, we do this. Then R2, we filter out from R3, the 10.10.3.0 route given to us. We filter out from R3, the 10.10.3.0 route given to us. Then let go of the one from R1, the 10.10.3.0 route given to us. For R2, 10.10.3.0 should go to R1 for R1. We choose the one from R3, the 10.10.3.0 route given to us. The next hop address is R3. After such a filter, we make R3 filter out, prohibit the announcement of the 10.10.3.0 entry. When R1 loses this entry, we'll send a query message to R2. R2 finds that the next hop of the routing entry is R1, then continue to send query to the back until the border. The border tells us that the routing entry is unreachable when it is not available. After replying with such a reply, we let R1 accept it through such a step so that we can see the third situation, classmates. Let's do this experiment. First on R2, we filter out the route from R3 on R2 router EIGRP 90. Using distribution list 1 in G01. We aim at the routing entries received from the 0.1 interface. We don't want its 10.10.3.0. Give up other routes. Then let go. No distribute list 1 in G00. Okay, we let go. Routing entries received from the 0.0 interface. In this way, R2 will receive from R1 the 10.10.3.0 route announced to us. We point to R1 on R3. We let go again, no delete 123. We said when we finished the last class, what is the trigger update of the routing entry? We have changed the delay, so we go to router EIGRP 90, no filter, for the 10.10.3.0 routing entry filter, so that R3 can give our R1, announce this one, 0.10.3.0 route. Then now R2 just can't receive routing entries from the right. After doing this on R1 show, IP route show IP EIGRP topology. Then we can receive from R3. The routing entry announced to us, point to R3. Then the rightmost routing entry mentioned in the routing table to tell our neighbors, teller 2, this routing entry of ours for R2 show IP EIGRP topology. We are pointing to R1. All right, students, next we will capture packets. Let's look at our third query mechanism situation. First, capture packets from 0, 0. Wait a moment. Capture packets from 0. 1, then capture packets from 0. 3. Here OK, 3 packets. Next, we will be on R. 3. We will filter out 0. 3 will be filtered out. This one announced to R110.10.3.0 route. When R1 loses this route entry, we will send a query to R2 in the packet above, the packet in the upper left corner. We will observe from R1 the query message sent to our R2 and observe the ACK replied by R2 on the link between R2 and R3 on the right. We will be able to observe. When R2 receives the query message, find that the next hop is R1. We will send a query message to R3, requesting information for the 10.10.3.0 entry. Then R3 will reply ACK and reply messages. But R2 won't receive it, because we said he filtered here. R2 will know. We'll receive the unavailability message of this entry. Then we will reply ACK to R1. In this way, they will go, delete this database entry, filter, when his packet is sent over. There will be an update packet here, indicating entry update, and query messages. You will see a lot of. These two are a little simpler. When our R1 loses this database entry immediately, we to R2 and to our R3 sent such a query message, requesting information for this 6 entry. R1 gave R3 the 10.10.3.0 entry. So I request his entry information. I can't answer. Then the same as above. So R1 gave R2. I can't answer this entry, so request entry information. So R2. After applying ACK, I found out. The next hop is R1. So immediately R2. You see, we to R3. Sent a query to my other AI training neighbors, then asked for this entry information. I also have a problem with this entry. There is a problem. So you tell me, are there any other paths to access R3 replied with a reply? You see, of course, R3's reply is normal. R3 said, so I can access but students for R2 to say it's not necessarily for R2 to say, so he filtered. So I don't accept from R3. Tell me the October 3rd 10 entry information for R2 to say, I think this entry is unanswerable. So R2 tells R1, we are R2. I don't approve of this path entry. I don't want this path entry for R2 to say there are no other neighbors. Then I think this entry is unanswerable. Tell R11 0.1 0.3.0 R2 tells R1. This is a reply message. The path entry is unreachable. The delay is infinite. There is no route at all. Then R1 replies with an ACK. I understand. Then this entry is deleted. And if so, after such a discussion, R1 successfully removes this entry from its database. The entry is deleted. Because R3 also tells R1, this entry is not available. Then for R1. You see the delay is infinity. Then for R1 after replying with ACK. We remove the EIGRP database entry truly from our database students, then it's deleted. After such a query mechanism, you see, we successfully resolved one unanswerable route entry information for R2. Then my route itself is what you gave me. Then after I query, I found that this entry has no other paths. I'm sorry, this route has no other paths. It's unanswerable. We delete this entry from the database. This is our EIGRP query mechanism. Of course, because we are filtering in the inbound direction of R2 filtering. So students can't see R3 telling R2, this route is not available. If you don't do this, I change it to outbound filtering. Let students see this message, then 0, 1. I'm sorry, router EIGRP 90. No distribute list 1 in G0, 1. On R3's side, distribute list 1 out, go to 0, 1. We filter this way, then we do this again, see this phenomenon. We go back to the original, do it again. Because students may feel, teacher, I didn't see R3 telling R2. This route is not available. Because we are filtering in the inbound direction of R2, R3's message is normal. We need to see the network boundary. Tell our router the next hop is unreachable. There are no other paths. Look at this data situation. A bit hungry. Soon, then, through the update data. Now all routers have it. R1 has this EIGRP database. All next hops point to R3. Then for R2, it has this EIGRP database entry. After all, the next hop points to R1. There is only this one. Then we do this on R3, distribute list 1 out, G03. We filter, then R1 will immediately lose an entry, send query to R2. R2 finds that the next hop is R1. Continue to send query to R3. Then R3 tells R1. This entry has no other paths. There are no other reachable paths. Then R2, delete database entry. Reply with a reply. R1 sends query to R2. R2 replies with ACK. The next hop is R1. Continue to send. Query R3's reply contains an infinite delay, indicating that this route entry is unreachable. Then R2 knows there are no other paths can access this. 10. 3.0. Then we delete this message through the database. Reply message to our R1. Then the route is unreachable. Then R1 deletes it. Reply with an ACK message students. This is the third scenario of our query mechanism. One thing students must pay attention to is the working method of the third scenario. So, are there any questions? About the 3 methods of the query mechanism, are there any questions? Students, I hope what I explained is clear and understandable. If students have any questions, you can ask directly. Are there any questions? If you have questions, ask directly. Don't hold back. If there are no questions, we will continue just now. Such a query mechanism actually has a drawback. Students may feel that such a EIGRP convergence, look how stable it is, right? Such convergence is too stable. We feel that this EIGRP distance, the game used is particularly robust, no matter if he chooses feasible successors method and his query mechanism, are all very robust. If we use such a plan, we can definitely find a route without loops, a routing entry without this kind of loop situation. Achieve convergence. However, there is actually a slight flaw. What is the flaw? This flaw comes from the third scenario we just mentioned. I often mention this scenario every time. A defect problem of the EIGRP query mechanism comes from the third scenario we just mentioned. All right, students, so what does this third scenario mean? Why is there a flaw? First, let's assume R1. At this moment, I announced a 10.10.1.0, 24 route entry into my database. Of course, R1 is announcing its own direct route, entering our database. Then this route entry can be told to R2 for R2 10.10.1.0. 24. The next hop is R1 for R 410.10.1.0. 24. The next hop is R2 for R3 10.10.1.0. 24. The next hop is R1 R5 10.1.0.1.0. The next hop is R1 R6 10.1.0.1.0. The next hop is R5, R7, 10.1.0.1.0. The next hop is R6, R8 10.10.1.0. The next hop is R7, students. Let's assume at this moment R1's loopback 0 interface is down. This root entry is lost from our R1's EIGRP database. R1 lost such a successor route and found that there is no feasible successor route. It will immediately send to all our EIGRP neighbors. Send to the destination address 224.0.0.10 of the EIGRP multicast address. Query message send query. Then for R2, I will send to R for all routers. Will, once a query message is received, immediately reply with an ACK indicating that your message, I received it. Confirm once, then for R5. We found that the next hop is R1. The route entry you gave me. My next hop is you. Then our third scenario. You have a problem. So, do I also have a problem? I need to see if this route entry can be saved. Is there any other path reachable? R5 will send to R6. Send query to my neighbor again. Similarly, R2 will send to R4. Send query. After receiving the query message, the first thing is to reply with an ACK. R4 also replies to R2 with an ACK. Then query R4 realizes I am the boundary. Apart from the router that sent me the query, I don't have any other EIGRP neighbors. And my next hop is you. The route entry you gave me, I don't have any other paths. R4 ensures. Ensures what? This route entry is really not available now, and there are no other paths. Can access 10.10, 1.0-R4 route. R4 gave up. So I am the boundary. Reply with a reply. R2 replies with an ACK after receiving the reply. Reply with ACK after receiving the reply message. So I know your message. There really are no other paths for the route entry. So after R2 received the reply, we'll continue to reply with a reply message upwards. R1 replies with ACK-so. R1 knows on this section of the path. There are no other routes to 10.10, 1.0-R4. What students need to pay attention to is only in the third case. Only after receiving the reply from the neighbor will continue to reply with a reply message. We only reply after receiving the reply. We'll reply with a reply message similarly. R3 realizes that I am also the boundary. I also have no other paths to access 10.10.1.0. I reply with a reply, there are no other paths. R1 replies with ACK-A students. So to R5, send query back to ACK. Find that the next hop is R5. Send query later. Reply with ACK later. The next hop is R6. The query you sent me. Send query later, a key. Reach the boundary. The boundary then replies with a reply, then reply with a reply, then go back. Have students ever considered a problem if the reply message from R8 can't reach R7 students? If we say our R8 router, the reply message we replied, can't reach R7. R7 can't receive R8's reply. What to do? Then R7 can't receive R8's reply. There is no way to reply to R6. R6 can't receive R7's reply. There is no way to reply to R. 5R5 can't receive R6's reply. There is no way to reply to R1. That is to say, for this section of the path. Once any router can't receive the reply message, there is no way to continue to reply with a reply message. So what would be the problem? R1 has always been unable to receive the reply message from this section of the path. R1 doesn't know if this 0.10.1.0 route. Is there any other reachable path? So I can't just delete it from the database. Keeping it in the database is not right either. I don't know how to handle this database entry, what to do then. So in our query, in the query timer, there is a query interval. Time, when the router sends a query message, it will start a query timer. The duration is 3 minutes, 3 minutes, 180 seconds, 180 seconds. So, during this time, students, within this period, if it exceeds 3 minutes without receiving link, neighbor's reply message, it is considered there is a fault with the link to the neighbor. Directly disconnect reset EIGRP neighbor relationship EIGRP neighbor relationship. Classmates, when our R1 sends a query, it will immediately start a timer. The duration is 3 minutes. So if after 3 minutes, for example R7 and R8, if the link fails, R7 cannot receive R8's reply. It can't reply to R6, R6, can't reply to R5, R5, can't reply to R1. If after 3 minutes, R1 does not receive the reply message from our path, then R1 does not receive R1. After more than 3 minutes, disconnect the EIGRP neighbor relationship with R5. R5 does not receive R6's reply. Disconnect the EIGRP neighbor relationship with R6. R6 does not receive R7's reply. Disconnect the EIGRP neighbor relationship with R7. R7 does not receive R8's reply. Disconnect R8's neighbor relationship because of a path relationship, because the link between R7 and R8 fails now in the network. This whole link must be given to him. What to do? Make compensation. The entire link must be reset. Disconnect the neighbor relationship. Then reestablish the EIGRP neighbor relationship through the hello packet classmates. What to do next? Update the route through the update data packet again. So after resetting the neighbor relationship like this, through the update data packet, establish through what? Through the hello packet. Establish a neighbor relationship through the update data packet. Re-announce the route. So at this time, we can also know, right? For example, we have not been receiving the reply to this October 1st 10 query. We don't know on this path. Are there any other paths? Can access 10.10.1.1. So once the neighbor relationship is reset, we update the route again through the update data packet, exchange routing entries. I can also know this routing entry. Are there any other paths left? Yes, classmates, because if you reestablish the neighbor relationship, we will send update data packets, update routing entries. So before I couldn't receive a reply, I don't know this routing entry. Can there be other paths? Now, after reestablishing the neighbor, resend the update data packet, I can still know this routing entry. Are there any other paths left? It just takes a little longer. The cost is a bit higher. But through this method, I can know this route. Are there any other paths left? This is also a solution, but the consequences are serious. This way you can indeed understand this routing entry. Can it still be used now? Are there any other paths? But there are a bit too many neighbor disconnections. Because of a link failure, reset the neighbor relationship. It's equivalent to the network being disconnected for a while. It's very serious, classmates. So, the problem with this query mechanism, it appears here because it can cause a whole link to fail. So, what to do to solve such a link? Failure information, to alleviate or prevent this situation. So, in this device, in our query mechanism, we say EIGRP is very stable. To avoid this situation, introduced SIA query, SIA query. So the message of SIA query. Actually very simple. After the router sends a query message, more than half the time of the query timer. No reply received. Then immediately send SIA query message. Immediately send SIA query message. Immediately send SIA query message. If received. If the router has received after the SIA query message, it will immediately reply with a SIA reply message, immediately reply with a SIA reply message. What can this do? It can confirm our link has not failed. The failure is somewhere else. EIGRP is relatively stable. What is it thinking itself? One, we send a query message. What if we don't receive a reply? More than a minute and a half has passed. Still no reply. We suspect that the link may have failed. What to do? For example, our disconnected link is here, between R8 and R7. R7 cannot receive such a reply message from R8. What to do? Of course, students will say, is it possible that after disconnecting this link, our router, the query message, R7 sends to R8, can't receive the ACK at all? What if the ACK is not received, students? Don't forget, we said whether it's R8's packet or in the query message. There is a secret number. Right, need to receive ACK for confirmation. If we send a query message and can't receive the ACK, then, we are not sure about this link. Whether there is a failure, we can't receive the ACK. Just know the neighbor on the other side did not receive the query I sent him. 16 retransmissions. Students, if the ACK is not received, we can't determine the reliability of this link. There are 16 retransmissions. So suppose we now can't receive the query message, then more than a minute and a half has passed. We, R1, send SIA query, send a special query mechanism to R5. R5 replies with SIA reply, then R1 knows our link has not failed. Why can't receive the query? Why can't receive the query's reason is not here with us. Then, even if the timer ends, more than 3 minutes have passed, then we also know it's not because of our link. That we can't receive the query, can't receive the reply message. Then our two neighbor relationships will not be reset. This indicates that our link has not failed. The failure is somewhere else. Then the neighbor relationship will not be reset. It has been reset. The same is true elsewhere. If R5 sends an SIA query to R6, R6 replies with an SIA reply to R5, then we know the problem is not here with us. Then if the timer exceeds, can't receive the reply, then our neighbor relationship, we should not reset similarly. R6 sends an SIA query to R7. Then R7 replies with an SIA reply to R6. Everyone knows this link has not failed. Then R7 sends to R8. If R8 can't reply with an SIA reply, if the SIA query sent is not received, SIA reply, this route will be set to SIA stuck state, stuck in the SIA query state, set to SIA stuck. It is stuck in the SIA query state. In this state, then after the timer exceeds, if still can't receive the reply, then reset the neighbor relationship. So students like this, through SIA query and reply messages, we can locate the point of failure. This can ensure some neighbor relationships will not be reset, will not cause a significant occurrence of fluctuations in the network. Classmates, so this is SIA query. Then we can see the corresponding phenomenon through the experiment. To see this corresponding phenomenon, this phenomenon can be seen. We do this. Block the link between our R1 and R3 first. We don't look at this link. Don't need this link. What's the situation now? Let me think about what the situation is now. What is the situation? Now 0. 3 is down. Down first R. 3 also removes this direction. Key. We return to this diagram. Look at this diagram. So R1, R2, R3, 3 routers. Let me see if there are any other situations. R2 should be. There is a filter here. It should be router EIGRP 90. Remove the distribution list 1 out. G, 0, 1. Does R2 have any more filters? Let's see, there should be no more filters on R2's side, it's gone. So now this diagram, classmates, this diagram, so let it converge for a while. Now R2 has the optimal route, pointing to R3. R1 has the optimal route pointing to R3. Okay, classmates, so we do this. Now for R3, then we are ready to do this. Look at another route. Look at R3's route. R3's 10.10.1.0 route points to R2's 10.10.1.0 route points to R1 like this. We will do a phenomenon later. First of all, then we on R3's side change R3's hello interval. Change our later time. Then change it to 65535 tell R2. If you don't receive your own hello packet for more than 65535 seconds, then disconnect our EIGRP neighbor relationship. Do this on R30, one interface IP later interval. Hold time, EIGRP 90. Change to 65535. Then do this, classmates. In a while, we will do an ACL filter between R2 and R1, between R2 and R3. Do an ACL filter. Do this on R2, access list 100, prohibit all from R3. Sent to us EIGRP packets 23, 3.0.0.0. Send to any destination address, EIGRP data traffic filter out. Then release some other. We have such a extended access control list. Prohibit all R3s. Such an EIGRP data volume of this list. Call it on R2's 0. One interface after the call is made. Classmates, let's input. See what happens in a while. Do this in a while. We disconnect R1's Lu Banming interface. For R1 successor route discarded. After losing the successor route, we send a query to R2 after R2 responds with an ACK. It is found that our route itself, 10.10.1.1, comes from R1. The next hop is so. We will continue to move forward, send query messages. But just because of the filtering, the link has failed. We can't receive from R3. The ACK message sent to us. Then this link has failed. That is to say, R2 can't receive from R3. The ACK sent to us can't receive from R3. Such a reply message, R2 will not receive a reply from R3 for a long time. So, therefore, R2 is very anxious here. R1 started a 3-minute timer. R2 started a 3-minute timer. After more than a minute and a half, that is half the time. After more than a minute and a half, we will send SIA query messages. To inquire about the link status with R3, R1 will send SIA query messages. Query messages. Inquire about the link status with R2, then between the two will be reconfirmed. Finally, R1 and R2 will not reset. The neighbor relationship, R2 and R3 will reset the neighbor relationship because exceeded the query time. Can't receive such a reply message from the other party in 3 minutes. Okay, students. Then we look at this phenomenon. Through such a filter, we do an operation. So why change the time to 6,535? Because for a long time can't receive such a R3's hello packet, causing our EI encryption neighbor relationship was reset in advance. Students then come to capture packets. Then the packet has been captured before. This is R1 and R2's, this is R2 and R3's. Here are 2 packets, then come on. This is R1 and R2's, we are here. Now the neighbor relationship between R1 and R3 is gone. We just downed the 0E3 link below. It's down. Just look at this picture. Hang an ACL on R2. Now R2 should not receive any from our R3 sent. Such a EIGRP packet. Okay, filtered. Now look at the packet. We do it once. R1 lost its successor. Root 10.10.1.1. Disconnect. Then immediately R1 sends query messages. Send query messages to R2. Request to query the information of this 0.1.0.1.1 item. Then R2 sends a query to R3. But R3's ACK was filtered by use. R2 unreachable R3. R2 will never receive from the routing item information given to us by R3. Then wait and wait and wait. Then wait until more than a minute and a half. We will see R1 will send SIA query to R2. R2 will also send SIA query to R3. Then it will reconfirm this information. Here in R1 show EIGRP topology 10.10.1.0-24. You will find that this item will currently be in query state waiting for one reply. Waiting for a reply. R2 will also find waiting for a reply message. Waiting for a reply. Then you will find that then what will appear here? Stuck in an SIA query state, we pay attention to this side. Wait for the SIA query note that there is a packet here. Wait for its SIA query 1.5 minutes. When did it start to disconnect? From 1793 plus 90 seconds. That is around 1880. There are about 10 seconds left, SIA query. Did we miss it? Not yet, right? Still waiting for reply. It's 1890 now. Where is your SIA query? Do you have it? No, he said he has it. I didn't see it. How long has it been? It's already confirmed, not here. Or did I count wrong? Check 1793. Here, 19, 10, 1793, plus 90, 1793, plus 90. Take a look. It should be 1,000. There should be no problem with this time delay. It doesn't matter, it's the same. So let's look at it immediately. R1 sent one to R2. The same SIA query. R2 replied with an ACK. Then what replied with an SIA reply? Look, it's confirmed. There is no problem between us. Right, classmates? Then R2 replied to R3 again. Look here, what did he say? He said, waiting for one reply. Then why didn't it appear here? What's the situation with 23.3? His SIA message. Now it's infinity waiting for. Why didn't I see it show IP route? Look here, I remember now. Here I was, wrong, here not here. Wait a moment, I want to see which table. Which table was it? EIGRP topology, is it him? I forgot which table. This is show IP, EIGRP topology, 10.10.1.0. Why didn't that entry appear? I'll send and reply, not this one. Which table was it? Is it the neighbor table? No, which table was it? I forgot which table it was. Stuck in SIA state. I remember which table it was. Show IP. Is this the right table? Did not add detailed information. Look here. Yes, found it 10.1.0.1.0 entry. No need to add that detailed entry. Look, stuck in SIA state. Cannot receive the SIA reply message from 23.3. So this is confirmed. The routing entry from our neighbor has a failure. You notice the preceding P has also become an A. We mentioned, if the routing entry is P, it means that this routing entry is in passive state. Then it is a stable state. Once the routing entry becomes A, becomes active, it means that the routing entry is unstable. In an active state, there is a bit of a problem with the routing entry. A bit of instability occurs. That's not right. Then you see the routing entry, SIA's query. Then you find that the EIGRP neighbor relationship between R2 and R3 has broken again. Waiting to be reestablished, EIGRP neighbor relationship. EIGRP neighbor relationship, reset it. Dear students, once we send the SIA query, then the status will be redetermined. The status of R1 and R2 has not changed. The neighbor relationship between R1 and R2 has not been reset. R2 and R3 have reset their neighbor relationship. Dear students, this is our query mechanism, such a stable method. EIGRP's query mechanism, how to seek stability. Any questions, students? Any questions, students? About EIGRP's query mechanism. Of course, all will be updated in the notes. You can see it in the notes. Then next, what's the time? It's 39. So, students, that's all for today. We won't talk about it later. Originally, I was thinking, today we will continue with limiting the scope of EIGRP, a summarization method. One is our EIGRP's finish, talking about stub routers, then give students a Labor Day holiday. After the rest, we directly do EIGRP Comprehensive Experiment. It seems a bit long. We set 6,535 for the purpose of preventing between R2 and R3. Due to filtering out EIGRP packets, including EIGRP's Hello World. Also filtered out. After filtering out this packet, then it leads to between the two of us, because R3's Hello packet is not received for a long time. Then directly disconnect the EIGRP neighbor relationship, because our purpose is very simple, is to disconnect R2 from receiving R3's EIGRP's ACK packet. Let us not receive R3's EIGRP ACK, so we change the hello time, change it later to 6,535. In this way, even if R2 does not receive R3's hello packet for a long time due to filtering, we will not disconnect the EIGRP neighbor relationship. At that time, because it can only be due to not receiving R3's ACK for a long time, we can't reply message. Then the neighbor relationship will be reset. The purpose of setting 6,535 is this: to prevent us from disconnecting the neighbor relationship due to not receiving the hello packet for a long time. The main phenomenon we see is because of not receiving query's reply message. Then I reset neighbor relationship. Dear students. That's our knowledge point for today. Most of the things have been discussed. We will wait for the next class to limit the scope of EIGRP query. Then we will do EIGRP's stub router. Does root leakage. Then we will enter EIGRP's comprehensive experiment. Dear students, if you have any questions, you can ask again. If there are no questions, that's all for today. Any questions, students? If there are no questions, that's all. Dear students, see you after the holiday. Wait until we are in May. When will we have class after the holiday? Let's see calendar. After the holiday is 6th TCP retransmission. You didn't filter, did you? Did you filter? If it's TCP retransmission, you keep sending this link. See if you have filtered TCP messages. Generally, you still filter the interface. Maybe only permit was done. No deny was written. May only have done permit. Did not write deny. It automatically denies any. See if any TCP connections are allowed. Traffic accessing one's own port. Is it allowed waiting for you?